Climate change is no longer a distant threat on the horizon. It is a present and escalating reality. The scientific consensus is unequivocal. An overwhelming 99.9% of peer-reviewed studies confirms that human activity is a dominant cause. The consequences of our inactions are already unfolding, painting a stark picture of our future. We are witnessing the first tremors of a planetary transformation. Rising global temperatures, breaching the critical 1.5% threshold, are triggering a cascade of effects, like intensifying extremes, more frequent and severe drought, hurricanes, and wildfires ravage communities and ecosystems. Acidifying oceans, absorbing excess carbon dioxide, our oceans are becoming more acidic, threatening marine life. Vanishing ice. Glaciers' retreat is altering freshwater supplies for millions, while melting ice caps accelerate sea level rise, threatening coastal cities with a perpetual flooding. A silent crisis. Biodiversity is collapsing as a species, especially in vulnerable tropical regions, face extinction. These changes are not abstract, they are human faces. Farmers watch their crops fail from drought or deluge, pushing families towards disappear. Disease-carrying insects like mosquitoes and ticks expand their range, bringing illness like dengue and Lyme further north. As wildlife habitats shift, dangerous human-animal interactions and the emergence of a new disease become more likely. So all these are the consequences of a climate change. We humans, हमने खुद paint किया अपना future with all our activities and creating a disaster to this globe. Now we can relate these all climate changes with chemistry into three main areas. How chemistry involved in all these changes. First, chemistry involved in climate changes, like the chemical causes. Main causes of climate changes are directly related to chemistry. I will explain it. Second, chemical monitoring and analysis. After chemical causes of global warming, we can use chemistry for monitoring and analyzing and diagnosing the problem we are facing. And thirdly, chemistry we can use for the chemical solutions, mitigations, and adaptations. So the first, we will study the relationship of chemistry and the climate change in terms of the chemical causes, the chemistry of greenhouse gases. At its core, climate change is driven by the altered chemical composition of Earth's atmosphere. This is primarily due to the increased concentration of greenhouse gases, which traps heat. The chemical composition of Earth atmosphere change हो रही है because greenhouse gases की accumulations और इनकी concentration increase होती जा रही है. ये greenhouse gases in heat traps करती हैं. The molecular mechanism, the greenhouse gases like carbon dioxide, methane, CH4 and nitrous oxide N2O have molecular structure with 3 or more atoms. अगर इन 3 greenhouse gases का आप structure देखें, carbon dioxide का, methane का और nitrous oxide का, इन तीनों का जो स्ट्रक्चर है या मॉलिक्यूल है, इसमें 3 मॉलिक्यूल्स इन्वॉल्व हैं. कार्बन डाइऑक्साइड में भी 3 मॉलिक्यूल्स हैं, मीथेन में भी एंड ऑक्साइड में भी इनका 3 से ज्यादा मीथेन में है. These structures allow them to absorb and re-emit infrared radiations, heat coming from the Earth's surface. As more molecules involved in these gases, so these can absorb and re-emit infrared radiations जो Earth's surface से आ रही हैं. Carbon dioxide or CO2 is a molecule composed of 1 carbon atom and 2 oxygen atom. It is a colorless, odorless gas that is slightly denser than air. Carbon dioxide is a greenhouse gas, which means it can trap heat in the atmosphere and contribute to the climate changes. Natural sources of carbon dioxide include volcanic activity and animal metabolism. Human activities such as the burning fossil fuels and deforestation also release large amount of carbon dioxide into the atmosphere. As you know, जो trees हैं या जितने भी forests हैं, they are good absorbers of carbon dioxide. As we are heading towards deforestation, so there are no medium to absorb carbon dioxide, so they accumulate in atmosphere. Increased level of this gas can cause a range of effect from ocean acidification to changes in weather patterns. Up till now, these were the chemical causes of climate change. Now we will come towards chemical monitoring and analyzing, diagnosing the problem. Here we use chemistry for analyzing and diagnosing this problem. अब chemical cause तो हो चुका है global warming के लिए. अब हम इसे chemistry को use करके किस तरह इसको analyze और diagnose कर सकते हैं इस problem को. तो इसका second relationship chemistry का इस sense में है. So chemistry provides a tool to measure the monitor that changes in our atmosphere and oceans with incredible precision, like isotope geochemistry. Scientists can analyze the ratio of carbon isotopes C12, C13, C14 in atmospheric carbon dioxide. The specific isotopic fingerprints confirm that the increase in overwhelmingly from the combustion of ancient fossil fuels. Similarly, ocean acidification is a direct consequence of increased atmospheric carbon dioxide is a reaction with seawater, a classic acid-base chemistry problem. For example, this carbon dioxide, when reacted with water, ocean's water, it forms H2CO3 carbonic acid, where hydrogen ions release and bicarbonates. The increase in hydrogen ion lowers the pH of the oceans, make it more acidic. Chemists precisely measure this pH change and study its impact on marine organisms that rely on carbonate ions to build their shells and skeleton, for example, corals, shellfish, etc. Now we come to ice core analysis. In ice core analysis, chemistry allows us to understand past climates by analyzing air bubbles trapped in ancient ice cores. Chemists can measure the concentration of greenhouse gases from hundreds of thousands of years ago. Now chemistry gave us chemical solution to all these problems. This until now we discuss about the chemical causes and then chemistry, how analyze and diagnose the problem. Now we will come towards solutions. How chemistry give us solutions to overcome these problems which are heading towards global warming. So chemistry give us chemical solution to these problems related to global warming. So one is a mitigation, मतलब इसके नुकसान को कम करना, and adaptation है. So chemistry giving us solution in form of mitigation and adaptation, where chemistry becomes a crucial part of the solution, developing technologies to reduce emission and removing existing gases from the atmosphere. Like carbon capturing, chemists develop advanced solvents, sorbents, and membranes that can selectively scrub carbon dioxide out of industrial exhaust streams or directly from the air, direct air capture. These processes often rely on the reactions like amines. When react with carbon dioxide and water, it form ammonium bicarbonates. So how they can capture carbon dioxide from the atmosphere? Now they capture carbon dioxide from the atmosphere to reduce its concentration. They utilize this carbon dioxide for different purposes. They use this carbon dioxide as a chemical feedstock through catalytic processes, another key area of chemistry. Carbon dioxide can be converted into valuable products like fuels, plastics, and construction material, turning a waste product into a resource. तो जो कार्बन डाइऑक्साइड वेस्ट प्रोडक्ट हो चुका था, अब उसको हम एज अ रिसोर्स यूज करेंगे केमिस्ट. Similarly, for storage, chemistry helps ensure the safe and permanent geological storage of carbon dioxide by predicting its interaction with surrounding rocks and brine. Renewable energy technologies like solar cells, batteries, also chemists are designing biodegradable polymers, plastics from renewable sources, not petroleum, and more efficient recycling process, chemical recycling, to reduce the carbon footprint of the material we use every day. Refrigerants and aerosols, chemists develop chlorofluorocarbons which damage the ozone layer. In response, then they develop a safer alternate refrigerants, HFCs, hydrofluorocarbons with a low global warming potentials. You know very well that before the gas used in the refrigerators, they are also cause ozone depletion. So in this response, chemists developed a safer alternative refrigerants, HFCs, with a low global warming potential.